Hello everyone. On this video we will be looking at the derivative of just general exponential functions. Alright, so starting off, what if we let y equals a to the power of x, where we know that a is a positive number greater than 0. Okay, so that lets us know that the derivative of a to the power of x is equal to a to the power of x times the natural log of a. Alright, so it's really quick proof, so let's go ahead and prove that that's the case. Okay, so we know that y is equal to a to the power of x. Alright, so if you remember, this is kind of a reference point. That x is equal to e to the power of natural log of x. So the e and the natural log kind of cancels each other out. Okay, so that means we can get this equation and we can rewrite it as y equals e to the natural log of a to the power of x. Okay, because the e and the natural log cancels out, you're just left with y equals a to the x. Okay, now if you remember the power rule for logarithms, so if you have the natural log of m to the power of p, that's going to equal p times the natural log of m. Okay, so the natural log of a to the power of x, you can just bring that x down to the front. So you have y equals e to the power of x natural log of a. Alright, so now we're going to get the derivative of y. So the derivative of y with respect to x is going to equal e to the natural log a to the power of x times the derivative of x natural log of a. Because remember, these two are the same, so you can have it written this way for one part and this way for the other. You're okay. Natural log of a to the x and x natural log of a is the exact same thing, so that's why it's kind of switched over. Alright, so from there, we can see that our dy dx is equal to the e and the natural log kind of cancels each other out. So you're left with a to the power of x times derivative of x natural log of a. Remember, your derivative of x, so you can get the natural log of a and kind of factor it out to the front. So you have the natural log of a times the derivative with respect to x of x, which is just 1. So that leaves you with natural log of a. So that leaves you a to the power of x natural log of a, which is what we have up there. Alright, and similarly, so you can put that down here also, the derivative of a, and instead of a to the power of x, let's say a to the power of some function of x, is equal to a to the power of that function of x, natural log of a, but you're multiplied by the derivative of that function of x. Alright, so if you are still writing, feel free to press pause, But we're going to go ahead and run through a quick example. I'm only going to do one example because you're literally just plugging things in. Alright, so let's say, for example, you want to find the derivative of y equals 2 to the x squared power. Alright, so to solve that one, of course, you have to remember your a to the g of x is equal to a to the power g of x times natural log of a times g prime of x. Okay, now with this one, just rewriting our original problem, y equals 2 to the x squared power, our a is equal to 2. And your g of x is your x squared. Alright, so that means from your g of x equals x squared, so that lets us know that your g prime of x is equal to 2x. So you have everything you need to plug right into there. So that means the derivative of 2 to the power of x squared is equal to a to the power of g of x, so 2 to the power of x squared, times the natural log of a, so that's the natural log of 2, times your g prime of x, which in this case is 2x. Okay, so really you can kind of combine those two and make that 2 to the power of x squared plus 1 x natural log 2. Uh-oh, sorry about that. Okay, so you just combine those 2's, you have your x still there, and just your natural log of 2. So that's why I'm only doing one example, because this one's pretty straightforward, and you're just plugging everything in. Alright, so hopefully this made sense, and I'll see you on the next video.